To factor any polynomial is to express it as a product of two or more polynomials which are irreducible. That is, polynomials which cannot be factored into polynomials of lower degree. There are several techniques in factoring polynomials. These are the common factor of highest degree, difference of squares, quadratic trinomial, perfect square trinomial, difference and sum of cubes, and by grouping.
Good day everyone. For today's video, we'll be discussing another technique in factoring polynomials, which is a perfect square trinomial. Okay, so a perfect square trinomial is any trinomial that is the result of squaring a binomial. Okay, so we have this form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. Okay, so a perfect square trinomial is in this form and this form also. Okay, so as you can see from the name itself, trinomial, so it consists of three terms. Okay, and then if a polynomial is in this form, this one, then we will use the factors a plus b squared or a minus b squared. Okay, so it will be emphasized later, but this time, before we start our examples, you need to have the necessary skills for you to understand the new skill or technique in factoring polynomials. So you must be equipped first with the basic skills in finding factors, adding integers, multiplying integers, multiplying polynomials, dividing polynomials, and special polynomials. Okay, so again, for perfect square trinomial, it should be in the form of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So the first term, a squared, it is the square of first term. First term of our trinomial, square of first term. The second term is twice the product of first and second term. So this one, 2ab, it is twice the product of first and second term. Then for the third term of our trinomial, it is the square of the last term. So it's b squared. Okay? Or the other form, we have a squared minus 2ab plus b squared. So the operation in the middle term, or for the second term, is minus. So it depends upon the sign of our middle term or the second term. Okay, so again, if polynomial is in this form, a squared plus 2ab plus b squared, then the factors would be the factors would be a plus b squared. Okay, then if the second term is minus, let's say a squared plus minus 2ab plus b squared, then the factors would be a minus b squared. If the second term, the sign of the second term is, the operation of the second term is minus. Okay, so the answers of the perfect square trinomial is a square of binomial. Square of binomial. As you can see, this one, a plus b squared, it is the square of binomial. The square of binomial. Okay, so let us have an example. Factor x squared plus 12x plus 36. Okay, so first things first, let us identify the operation of the middle term or the second term. The second term is 12x, then the sign is plus. Okay, so therefore we are going to use a plus b squared. So let's say the operation of the second term is minus, let's say x squared minus 12x plus 36. Then we will use a minus b squared. Okay, so again, careful of the operation of the middle term. If the operation of the middle term or the second term is plus, so we'll use a plus b squared. If it is minus, so we'll use a minus b squared. So in our example, the operation of the middle term is plus, so therefore we'll use a plus b squared. Okay, so next step, we are going to identify our a. So how to get a, we are just going to take the square root of the first term. The first term is x squared, so take the square root. We have square root of x squared, that is x. Okay, then for our b, how to get b? To get b, just take the square root of the third term. The third term is 36, so square root of 36, that is now our b. So we have 6. Okay, so let us try to check if twice the product of a and b is 12. So we have 2 times x times 6. 2 times x times 6, that is equal to 12x. Okay, so it satisfies the condition, so therefore we can use the square of binomial, or a plus b squared. Okay, so it is now easy for us to get the factors. So for our factors now, we now have a plus b squared, where a is equal to x and b is equal to 6. So therefore, we now have, as our factors, we have x plus 6 squared. Okay, so this is now our factor. So if you want to check if your answer is correct, just use FOIL method. Okay, so FOIL method, that is x plus 6 times x plus 6. Okay, x plus 6 times x plus 6. So apply FOIL method. We have x times x is x squared, then x times positive 6, positive 6x, then 6 times x is positive 6x, then 6 times 6 is 36. Okay, 36. 36. Okay, that is 36. Okay, plus 36. Then simplify. 6x plus 6x is 12x. So our answer is x squared plus 12x plus 36, applying the FOIL method. So therefore, we now have the same given. We need to apply the FOIL method. So therefore, we got the correct factors. So again, the factors, our factor is x plus 6 squared. Okay, so let's have another example. So factor x squared minus 14x plus 49. So again, let us identify, let us try to check first the operation of the middle term. The operation is minus. So therefore, we will use a minus b squared. So let us identify our a. So take the square root of the first term. The first term is x squared. The square root of x squared, that is x. So for b, take the square root of the third term. The third term is 49. So square root of 49 is 7. Okay. Then for the middle term, let us multiply x times 7, then multiplied by 2, or twice the product of the first term and the third term, or a and b. Okay, so 2 times x is 2x, then times 7 is 14x. So that's our middle term. So for the middle term, as you can see, the operation is minus, so
the sign of the middle term is can be used only in determining the sign of our binomial being squared. Okay, so we now have the value of a, the value of b. So therefore, our factors now would be this one. Okay, so our factors now would be a again is x minus b is 7 squared. Okay, so this is now our factors. Very easy. So if you want to check if your answer is correct, just apply the FOIL method. The first, outer, inner, and last. Okay, so that's it for the perfect square trinomial.